Hi, I'm Samit4 from ECG.net. In this tutorial we are going to create the actual fluid drop effect, and you can see this is our file scene, and I just created the water flow like this. And you can see if I play, a little heavier to play, but you can see a lot of nice fluid is forming. You can see if I skip to 100th frame, you can see a lot of fine smoother mesh like this, and we are going to stimulate this effect. You can see a little bit of drop start forming like this, and this is the effect we are going to create. So first of all, I'm going to open my scene, and I already simulated some settings here. I'm just going to delete that, and this also delete. And we have so many layers here. You can see there I simply moved the actual bottle to a new layer like this, and also I just deleted the inside filled water itself. So we have a simple board like this, and go to physics tab. You can see this is the physics tab. Click that and simply select the fluid tab, and you can see a type. Just select that as an obstacle. So this is going to be an obstacle for the fluid itself, and we have a shell object because it has an outer and inner volume, so we are using the shell itself, and we don't need any slipping of the or any stickiness for the fluid, so just use no slip, so that will cause the fluid to fall within this object. We need to add an emitter also, so I'm going to add a mesh, a sphere. Just move to top, and in the camera you see it's just above the camera. Okay, I'm going to scale it a little down like this, so maybe it should be at the center like this. So we are going to fill this area, so I just need to be small, and I'm just going to apply the scale value. So Ctrl A and select the scale, so that will apply. If I just undo that, you can see Ctrl A, Ctrl Z. So this is the scale value. Now I'm just going to apply this, press Ctrl A and press scale. That will create a 1:1:1 scale. For that is for just for visual purpose, and still we don't have any fluid in this, so click that, and I'm going to rename it to an emitter, so we can select it later. And also we don't need it to be rendered, so we can move it to the layer later. And in the physics tab you can just use a fluid and use an inflow, because we need the flow of the fluid for the rest of the scene. So I'm just using inflow, and you can see that a volume, and we need some initial velocity, so our fluid will be flowing downward like so in the -z axis. So I'm just using -z -2 value, and that will cause the fluid to flow downward. And if we play the scene, nothing happens, and that is because we need to add the actual fluid itself in order to create a cube, and this will be our container. So rename it as you can just rename it as fluid itself, fluid, and just move it like this. So a scale in the z-axis like this. So sorry, little bit like this. Okay, so just covering like, and maybe little bit. Okay, so we have a container, and that is, so we have a container, and this will be for our fluid itself. So just select the physics tab and use a fluid and use a domain. So you can see now it's changed our actual fluid itself. So before that, I'm just going to undo that. Before that, we need to set something. So now you can see the scale values are different. I'm going to apply Ctrl A and press scale value. So this will be for our scale value, and you can avoid this step if you want, but I'm just using it. And just simply enable the fluid value and the physics and press domain, and that will add some particles itself. So don't worry about that, you won't see anything because I already created some here. And here you can see a cache fluid value. You can just click that and you can rename another folder so that will be calculated for the cache value. So I'm just using water fluid cache. Press accept, and that will cause and that to disappear, so there won't be anything because we doesn't have any stimulation. So first of all, you can see there are a lot of options here, start, end, speed, and there are some options. I'm not going to change anything. You need to check with that at the actual real world size, and for the settings I'm just having a nearly equal 0.5 meters length cube, and this will be less than half a meter, so this will be just perfect for the scene. And also you can see the slip type is just turn no slip value, and there are some other options. I'm just don't use remove air bubbles, and we can experiment with these settings later. Just save the scene. So I'm just saving the scene. Already I saved the scene as just save the scene, and you need to check this area. So this is the area we are going to pick, and you can see the required memory itself. So keep an eye on this, depending on the size of the scene and all settings, resolution and everything. This will be going to be too much heavy. So this does need a 2.33 MB RAM, so maybe roughly equal to 200 MB RAM. You can see this is the actual usage, 214 MB and 2%, and also this is having some simulation threads, but I don't know, but I think the Blender physics that fluid simulation is not multi-threaded. And simply press the back required memory, and you can see that will be calculating. And if you check now, you can see a little bit higher value for the RAM itself, and only 26% for the RAM total CPU usage. That means only one processor is using for the actual simulation, so that will take much time to calculate, so wait for that. Okay, we just finished our simulation, and you can see this is the actual file. If we play scene, you can see a lot of problem occurring, but this is the actual rough simulation we are going to use. And see, and you can see a lot of cubes, and that is because the resolution, and this is set to preview resolution. If I just use the actual final resolution, and you can see a little bit fluid like objects here. And if I use a smooth shading also, you can see some sort of fluid, but it is not like an actual water itself, and you can see it is not like a filling actual bottle. So we need to adjust the behavior. First of all, we are going to add a keyframe for the inflow value, and you can see at the Z value at the 50 frame I need the actual flow, so I'm just going to insert a single keyframe value here, and maybe at the 55th key frame I'm just using 8 to a 0 value, just insert a single keyframe value, and at the 16th frame just using another keyframe here for the type. Right click that and insert keyframe, and at the 61 I'm just turning off this enable value and use insert keyframe. That will cause the actual emitter to stop emitting fluid, and we will get some nice stopping of the fluid effect, and we need to restimulate again. Before that, we are going to add some more settings and detailing for this. So now it's too big to stimulate, and it is not fitting inside this bottle itself, so we need to adjust that. Before that, I'm just going to use the resolution value. You can see I'm just using 150, and it is not that much resolution. You can use 200, 300. And now you can see the back record memory is increased to 26.88 MB, and this will take too much time to calculate also. So I'm just using that final 150, and I'm going to use this base one, and I'm just using to increase it to 10 exponent. And also you can see the fluid boundary value, the surface smoothing should be 1 and the subdivision value to 2. That will create a lot of subdivision to the fluid to calculate the shape, so that we will get the definite shape of this container or that bottle itself. And I'm just going to use a tracer value to 10, so we will get some more particles. And also I'm going to use generate value to 0.001, and that will create some tiny droplets necessary for this fluid simulation. We're going to save the scene once again and simply bake the scene, and it will take some time to calculate it. So you can see now it is 116, and this will slowly starting to bake. And also see our task manager now, it's using much more RAM, still using lesser CPU. Okay, we just finished our stimulation, and one more thing, I just made one more settings here. Just scaled our emitter to this match dimension, let me 0.311, so it should be just perfectly fitting inside our mesh, so it's too small like this. So our fluid won't outflow with the mesh itself. So this, and this is the final stimulation. You can see a lot of things happening like this. I play again. So this is our actual mesh. See, now we have a simple flow like this, and also this is too speedy, but I don't want to adjust the speed now because this is the effect I just want. Maybe in the next tutorial we can discuss about the speed things or anything like that. And this is the just like that. And now we have some problem with the mesh itself. If I just move it and the layer, and if you see small, also you can see a lot of jagginess or irregular mesh here. Okay, so we have to smoothen the things out, and I want to show you one more thing. And this is another stimulation. I did the very same settings but with more resolution, 300, and you can see I reduced the speed to 0.40, and you can see some nice effect with the particle itself. So you can experiment with this value, and you can see a lot of nice flowing particles. Some drops are moving upward, and some are very slowly doing something. So you can just get some slow, ultra slow motion effect with the speed itself. So just keep experimenting with these values. So maybe in the next couple of tutorials we can discuss about this kind of settings. Okay, so just splitting the scene. So this is the final stimulated fluid we want to adjust. So now we have this like this, and we need to fit this inside this jar, this glass bottle perfectly. In order to do that, we need to do some adjustment. So first of all, we need to duplicate this inner surface only. In order to do that, just go to here, just in the edit mode. So you can see in edit mode, simply go to the face selection mode, select the bottom face and simply change it to the edge mode so that edge will be selected. Select any of the outer edge, press Ctrl E edge loop, and again Ctrl E edge loop inner region, that will be selected inside. Press Shift D, that will duplicate, and press P and value spot. So you will be get bottle, and I'm going to rename it as inner for boolean. This is bottle for inner boolean region. Move it to another layer. We can move it to the very same layer where our fluid is. So we have our bottle inner region and actual fluid itself. So maybe in the last portion, now we can see our fluid is now touching with the outer region. So I'm just going to increase its scale value a little bit higher. You can see this is our actual scale value. So I'm going to increase it a little bit higher, like this, something like this, and also move it upward so it just fits the scene. Okay, so we are going to use the boolean operation for this, and in the modifier tab, add a boolean modifier and select our object, whatever I just created, and that will be bottle inner for boolean. Simply select that. That will cause something like this, and you can see now still we are not getting anything similar, only intersect region is showing. So we need to change the intersect to difference, so that will create some interesting effect. So I'm just going to move. Now you can see a little bit problem is occurring at this region, so we need to increase the scale value a little bit higher. So increase a little bit higher value, so that region is gone. Okay. So now we get a perfectly shaped outer fluid, and we just move this to another layer, maybe to the next layer. Now you can see a perfect shaped fluid. So just play the scene again, and you can see now we have just perfect fluid. This fit with our actual bottle itself. And if you want more smoothness to this area, you can just add another modifier. So select our fluid itself and add another modifier named smoother. Don't use the subdivision surface here, because it will simply add so much polygons, and that will cause the system to slow down and the rendering to hang up. So just use the smooth option. That will add some smoothness to here without adding any polygons. So if you just increase the factor a little bit higher, and see now these areas you can simply increase and the smoothness whatever you want. I think each one, so there is too much smoothness. And if you're having any distortion here, you can just simply increase the scale value a little bit higher and play the scene. Now it will take a little bit more time to calculate, but you will get a nice looking fluid effect. So we have our water itself. I'm just going to see what's happening. Now you can easily change to the rendered mode and see what's happening. Okay, so we have our actual flowing water with the static water input. So go and set your render settings and increase the sampling and the light path to the full global illumination. So keep watching from MeCG.net and catch more interesting tutorial. Maybe in the next section we can add some bubbles, water bubbles with this fluid, and also some water droplets. So keep subscribed for MeCG.net and our YouTube channel for MeCG.